Welcome to solverfy.
This is chapter 27, problem number 30. We have ionized potassium atom, and it is under the influence of electric and magnetic fields, both of them. And we are asked to calculate the speed at which the atom would go undeflected. For that to happen, we have to have the electric force acting on the atom equals to the magnetic force. Q times E equals QVB. We're also given that this velocity is perpendicular to the magnetic field, so I'm dropping the sign term. When we cancel charges, since we have on both sides, in order to calculate the electric field, well, here is the equation. The speed times the magnitude of the magnetic field gives us the magnitude of the electric field. So 4.5 times 10 to the power 3 is given to us as the speed, and the external magnetic field is given to us as 0.025 Teslas. So then we find our electric field to be 112.5 newtons per coulomb. And in part B, there is no electric field anymore, but we have a different magnetic field, a different strength. So QVB prime, we're going to call this new magnetic field. This is going to be equal to mv squared over r from Newton's second law. So in this part, we are actually asked to calculate the value of b prime if our radius, the radius of the atom is 12.5 centimeters. So then we need to isolate b prime out of this equation. First, let's get rid of the speeds, and then b prime is going to be equal to mv over q times r. So the mass is given to us in a problem as 6.64 times 10 to the power of negative 26 times the speed is 4.5 times 10 to the power of 3 meters per second, divided by, since it's an ion, it's going to have 1.6 times 10 to the power of negative 19 charge, coulomb charge, and we have the radius given as 12.5 times 10 to the power of negative 2. I did a conversion to meters from centimeters. So then when we plug everything in, we find the magnitude of the new magnetic field to be 0.015 Tesla.